Hey everyone, welcome to an update on what's been happening over the last few months. After discovering some serious issues with the behaviour of gears in certain situations, I ended up having to completely scrap and redo the gear physics system. I also had to make some changes to improve the behaviour of fast spinning stuff like gears and axles. These under-the-hood improvements took up most of my time, but I also worked on a few other new things in the game. So let's have a look at these now. Okay, so previously in the game, when you were building a construction, gears that were next to each other would be considered to be engaged or meshed together, but only at the point that they're placed in the construction when it's frozen. Now if we freeze this one, you'll see that these gears, when the construction is actually being built, were not next to each other and so wouldn't be considered engaged. Now previously, once the construction was unfrozen and all the parts started moving about, the gears wouldn't dynamically engage together. It would just remain at whatever state it started out as. Now I've fixed that, and so gears will dynamically engage and disengage with each other. So we can see that if I unfreeze this. So hopefully you can see that as the gears swing past each other, they engage and then disengage as they get nearer and then further apart from each other. Let's have a look at that again. Okay, so I've also added some other gear types into the game. One of these is a rack gear. Now this is a gear that will engage with spur gears and convert effectively rotational movement into linear movement. And again, this example shows off the dynamic gear engagement. So if I freeze this construction and then unfreeze it, you can see the gear engaging and disengaging, and as it meshes with the rack gear, it converts that to kind of rotation with the spur gear here. So let's have another look at that one. So this just means that with the dynamic gear engagement, it means that the gears behave more correctly, and you can start to build more interesting constructions because you can have gears that purposefully, engage and disengage for whatever reason you want to do that. As for the rack gear, that sort of obvious application for that is for rack and pinion steering, but you can sort of think of using it for driving moving platforms and lifts and things like that. Eventually I want to add in a slider attachment that will let you have parts that slide past each other but still kind of lock together, and that will be really useful in that situation. Okay. The other gear type I added was a crown gear, and this engages with spur gears, and a bit like a pair of bevel gears, it kind of takes the rotation through 90 degrees. But it gives you some different gear ratios, and also, especially with this small spur gear here, you can kind of fit things in a slightly smaller space than you could with bevel gears. So let's have a look at that working. And there's a couple of different crown gear sizes. There's only one rack gear size, but you can effectively create longer ones by just placing a bunch of them next to each other. So there's not really any limit to that. Okay. I've also added another part, which is a steering wheel part. It's actually more like a control wheel, really. You can use it for lots of applications. The steering wheel is kind of the obvious one. So the way it works is it operates a little bit like a motor, but instead of spinning things that are attached to it, it spins itself in response to controller input. So if I hold down Shift and then press W and S, you can see it's just rotating itself. And then I can bring up, if I hold down Shift and then hold down E, I can bring up the part behavior menu, just like with motors and everything else. I could switch it to horizontal controls if I like, and that's then moving on, holding Shift and A and D. And then if I attach this to an axle, and you can see it spins in response to the user input. Right, so let's have a look at these new parts in the context of something a bit more interesting. So here's little car thing. So you can see here, you know, quite a sort of usual application for crown and pinion would be to take the drive shaft output and drive the output axle on a car. So you can see that happening here. You can see there's a spur gear here that's meshing with the rack gear for our rack and pinion steering. And let me just grab the side of this thing so we can see what's happening. So here you can see I've actually got two motors here through this gear and this gear coming from each motor, obviously, and then that's driving one gear onto the drive shaft and gives me a bit more power because it's quite a heavy vehicle. This crown gear isn't doing anything other than just to show that the drive shaft is spinning and act as a kind of fake flywheel, if you like. So just for a bit of fun. The rack and pinion steering, you can see, is actually coming through here as kind of a shaft that's coming off, and then it's going up through a bunch of spur gears up to the steering wheel. So if we unfreeze this, now everything's working fully physically, so you know it's kind of operating both ways. So as the wheels kind of influence the movement of this steering track arm here, it actually feeds back into the steering wheel, and you can kind of, I don't know if it's very easy to see that, but if the car rolls back a bit, you can see the steering moves and it's kind of driving the steering wheel. And then conversely, if I switch the steering wheel on, and remember it's set up right now to use shift A and D, so remember that's going to turn the steering, so you can see the forces from the steering wheel actually being propagated through all of these gears and then driving the steering. Now what's interesting about the steering is because these axles are mounted slightly behind the pivot point of these arms here, it means the steering will kind of automatically self-center as when the vehicle's moving forward. In fact, let's show that right now. So if I just turn on these motors, and these are set up to work on shift W and D, so if I press W, the car moves forward, and you can see that the steering centered itself. I'm not turning the steering at the moment, it's just doing that by itself. But then obviously I can turn the steering as well. And you can kind of see it's all working pretty nicely. But what I really like about it is the fact that the forces through the steering are actually going, it's kind of propagating both ways, which is quite nice. So the steering actually becomes harder to turn as the vehicle travels faster because there's more self-centering effect happening. In fact, we can have a look at that now. So let's drive around. So you can see, traveling slowly, the steering quite easily will turn both directions. But as I move faster, it won't quite turn quite as far. You can see it's starting to become more difficult to turn. Whoops. Slow it down a bit. So it kind of gives that sort of realistic self-centering effect, which is quite cool. Now also, what you could do, instead of using the steering wheel, you could use a servo motor, which is kind of the way that I've shown doing steering before. So we can just pop a servo, let's say here. Hopefully that's going to attach itself to that. Yeah, so I've just turned off the steering wheel, so that's not doing anything anymore. And I'm instead going to turn this thing on we'll use the horizontal controls. I've just got to switch the direction, and let's change the max angle as well. See if I get this thing to roll away. And there you go, you can see now I'm using the servo to drive the thing. And you see it's much more rigid now. It's not having, the self-centering effect has been counteracted by the servo, but it gives you a bit more precise controls. So you have two options really of how you want to do it. Okay, well that kind of wraps it up. There's been quite a few changes over the last few months. Hopefully the physics should be quite a bit more robust than it was before, and the new parts that I've added should add quite a bit more flexibility as to what you can build. Okay, well that's it. Thanks for watching.